I love this question, even though everybody gets it wrong, because it lets me as a tutor explain something that is so fundamental to the SAT. This is like a perfect example of how they operate and try to make you to make mistakes. They force errors, right? They know you're smart and they know that you know stuff, and they use what you know against you to get stuff wrong anyway. So let me just stop talking big picture and actually get into the question. You'll see what I mean. Here is what most people do. They say, oh, I've got a line. I know to get back to basics, let's think about y equals mx plus b, right? Y equals mx plus b. So my y-intercept is 5. Therefore, A and D are wrong because they don't have y-intercepts at all. And then the slope is rise 3, run 4. 3, 4. Rise 3, run 4, right? 3 boxes up, 4 to the right. Rise over run is 3 over 4. That is choice B. But if you're watching this video, you probably picked choice B, and you probably already know it's wrong because you're watching the video to see what you did. Well, you fell for a classic SAT trap, okay? They know that every time you've ever calculated slope from a graph, you've counted the boxes. They know you do it. They know how to do it, okay? And so what do? They made the boxes mislead you, knowing that you're so used to doing that you don't even stop to think about why it works. It's just a robot brain thing. Your robot brain just is programmed really well by your teachers, and it's just going in and just doing running the program it's always done. But the boxes don't mean what we think that they mean, right? Normally when we see boxes on our graphs, they all mean the same thing. They're usually just one unit. But if we look here, 3 boxes is indeed 3 units, right? 8, 9, 10, 11. But 4 boxes? No. 4 boxes is just 1 hour. So if we're going to do rise over run using those numbers, using those boxes, our rise of 3 boxes is totally fine. But our run, it's not 4 boxes, it's 1 hour. So that's 3 over 1, which is a slope of 3, which matches with the correct answer of choice C. Okay, that's the correct slope as presented by the actual data, right? So how do we avoid this mistake? Well, number one, easiest thing, and this is going to work on all sorts of questions, is you cannot ignore scale. The SAT knows that when you do math in school, you very rarely even have to think about scale because you're graphing on the same kinds of axes all the time, right? Everything is equal to 1, right? All the boxes are the same. Everything is easy. It's a perfect world. But the world is not perfect itself, and so they give you these stories where the scale reflects whatever's going on in the story. And so you need to be able to look for that and account for it. So anytime you have a graph, you have to look at scale. They will absolutely try to use the scale to manipulate you. But there's a better way to avoid the mistake without having to think about all that stuff. And it's to use a much more basic strategy that I think gets ignored way too much. Plug points into equations. When I look at this question, I don't see the graph at first. I see the equations. And I know that this strategy is a very valuable one. So I say, okay, I've got equations. It'd be really great if I had a point to go with them, right? Because if I have a point, then plug the points into the equation. So where you're looking for 2 points and finding the slope between them, I'm not. I'm looking for 1 point. And I'm saying, okay, how about this right here? This point is 1, 8, okay? So 1, 8. How does that fit in these equations? Well, even the ones I eliminated easily, I can see 8 is equal to 5 times 1. No, that's not true. 8 is equal to 3/4 of 1 plus 5. Now, even without the calculator, I know that this is not going to work out, right? 3/4 times 1 is just 3/4. So I'm 3/4 plus 5, that's a fraction answer. So this answer choice, that's really, really tempting if we look at the graph and let our robot brain take over. It's just not even part of my consideration here. It's so obviously wrong because the numbers don't make sense when I plug that point in. Whereas choice C is going to work out just fine, right? So 8 is equal to 3 times 1 plus 5. Well, yeah, 3 plus 5 is 8, so that makes sense. And then here, okay, they switched up x and y, which is weird. But there you go. 1 is equal to 3 times 8? No. And just like that, I would have picked C without even encountering the problem that most of you probably did encounter, this problem of scale, this problem of counting boxes. So our goal on the SAT, big picture, is to give ourselves methods that will decrease the possibility of a careless mistake, like this one, like picking choice B here. Knowing that the SAT is going to do certain things to try to manipulate us and try to trick us, we need to counter their move with different moves. Plug points into equations is one of the most powerful counter moves that you have in your SAT arsenal. Okay? If you're not regularly using it, you might not be doing terribly, but you're probably opening the door to lots of careless mistakes or overthinking of questions or whatever. And so that is going to cost you in the long run. So when you've got graphs, definitely check the scale. But if you can, plug points into equations is the best way to go because it kind of beats the SAT at its own game and makes a lot of their tactics go away. It's a safer bet. And on the SAT, safer bets mean more points.